Washington State University. Go Cougs!
Hello everyone. In this video, we're going to cover Lesson 4 of the Activity Change Detection module. In the previous lesson, we began our discussion of activity density maps. In this lesson, we're going to finish our discussion by taking a look at how we can beautify our initial ADM with nice X and Y axis labels as well as grid lines. We'll close our discussion today by looking at another example of using ADMs by resampling our data frames to different time intervals, similar to how the original authors, Wong and colleagues, had their data frames, had their ADMs shown for hourly data. So let's begin by looking at the changes we're going to make in our ADM Part 2, beautifying the plot. So we're going to add X-axis labels for each date instead of the day number in the sequence. So that's going to be these X-axis labels down here. We're also going to add X-axis labels on the top for the day of the week that the day corresponds to. So for example, October 1st, 2015 was a Thursday. So adding these two labels is really going to help our ADM readers gain context for the data. For example, looking at this Saturday and this Sunday, the 3rd and the 4th, we see that this particular individual probably went for a hike or a run because it was the weekend, whereas the other days that are during the week, they seem to be more consistent, perhaps because this person has a desk job. We're also going to add vertical grid lines to our heat map. As far as beautifying the y-axis, on both the left and the right side, we're going to add labels for the hour of the day. So 12 a.m., 1 a.m., 2 a.m., etc. We'll also add horizontal grid lines no matter what the resampling period is for our data. So right now in this example, we're still plotting minute by minute information, but we're going to fix our grid lines to be at hours of the day. So let's take a look at the code from the previous lesson, which I've copied and pasted here. I've changed the code a little bit, so we no longer need to read in all 21 of those files. We can read in the steps CSV that we wrote from our steps data frame in the previous lesson and take off from there. Okay, so our code is run and we see our initial ADM here. So this is kind of our starting point and this is our goal for our ending point. I've divided the changes we're going to make into the x-axis and the y-axis. We'll start with the x-axis. I've already written the code and I'm not going to type it in order to save on time. I'm just going to point out the key parts of the code and I encourage you to look through the rest if you're interested. So let's start with the setup x-axis function here. So here we're going to get the date labels from the steps data frame columns and figure out how many days there are. That's num days. Then we're going to set a major tick locator corresponding to 0 to num days minus 1. So that'll start at 0 to num days minus 1 and put ticks in the center of every one of our day columns. So a tick here, a tick here, a tick here, a tick here, etc. Then for each tick, instead of having a numeric label associated with it, we're going to set the tick labels to be our date labels, which we got from our steps data frame columns. Then we're going to go through and set each tick to be non-visible. The reason why we're going to set each tick to be non-visible is because we don't really need ticks in the center of our columns. The location of our labels will identify which column they're associated with. I'll also point out that I have performed a 90-degree rotation of these labels and aligned them in the center. That is the code here, keywords rotation and HA for horizontal alignment to the xtick labels method. Next, I set up a minor tick locator so that we can have grid lines that are in between our date labels. So in between our date labels, are these locations here, and that is where we set our minor ticks, and our minor ticks are used for our grid lines. And here's our grid line set to minor and a solid black line. Now let's take a look at setup top axis. So setup top x-axis is going to add the day of the week labels up here. So what we're going to do in this code is we're going to find out how many days there are, and we're going to find out labels for each one of those days by this function getDaysOfWeek. GetDaysOfWeek is going to follow an example in the Python datetime module, which is available at this link here, and it goes through an example of how to use stir ptime and stir ftime in order to find out the day of the week corresponding to a certain date. And I'd like to point out that these are full strings stored in weekday, and I'm just grabbing the first two characters to make a shortened version that'll fit in the top. Back to our setup top x-axis. So now we need to add a second axis to our figure. This axis is going to be used for our top labels. So we set the label top to on for our second axis tick parameters, but all of the other labels are set to off. We set the same x limits as our primary axes, and then we're going to set the major locators to be the same as for our primary axis. So we have np.arrange for num days. So this will be 0 through 20, just like we did in our previous example up here for our bottom x-axis labels. And then we set those ticks labels to be our days of the week strings. And once again, we're going to set these ticks to be non-visible because there's no need to have tick labels up here in the center of our columns. Now we're ready to take a look at our y-axis modifications. So our y-axis modifications, we're going to go through and set hours of the day labels on the left and the right side. So first, let's find out how many indices are in our data frame index. So we'll store that in num indices. We'll use it later. No matter what num indices is, we're going to always have 24-hour labels. And I'm going to construct these 24-hour labels using a list comprehension for each timestamp in the date range 0 through 23 inclusive with a frequency of 60 minutes. T is for minutes. So essentially for each hour in a 24-hour time frame, we'll go ahead and get a shortened version of that timestamp so that we'll have the hour, and this %p is for AM and PM. And that will give us 24-hour labels that look like this. Now we have our hour labels and we know how many indices there are in the data frame. Then we're ready to set up our major ticks and our minor ticks. So our major ticks are going to fall on our locations in the center of our rows. Here's some math here that is going to figure out where to put these major tick locations based on the number of indices, because if we've resampled our data frame, then this is going to change the scale for our y-axis. So we want our code to be extensible no matter how many indices there are in our date time index. Then once we've identified the location, then we're going to set the labels for each one of our ticks to be the hour labels. And just like we did for our x-axis top and bottom, we're going to go ahead and set our y-axis ticks to be non-visible as well. Now the minor ticks are for our horizontal grid lines. Very similar math here as we had for finding our major tick locators. We're going to set the minor formatter to be a null formatter so that there's no text associated with it. And we'll set the grid to be the minor tick lines, which we set here with our minor locator. And lastly, we're going to set our tick parameters such that the labels on the right side are also on. So this is essentially going to double up on our left labels and our right labels. Now that we've set up our y-axis and our x-axis modifications, we are ready to test out this code. So all we're going to do here is write a function. Let's call it ADM beautified. We're going to receive the data frame and a title label. We'll call our original ADM in order to make the heat map, because that's not going to change. We will wait on showing our plot until we are done adding our bells and whistles. Let's set the plot's title to be title label, but something a little bit different than the title set in our original ADM function is I'm going to set its location to be slightly above, that's this part here, our top of our axes. Next, let's call setup x-axes. Run this code. So it's in our namespace. So setup x-axes, passing in our data frame and the current axes. Set up the y-axes, passing in the same parameters, and then setting up our top x-axes, and this time we need to pass in our data frame, the current figure reference, and the current axes reference. And now we are ready to show our plot. We'll call ADM beautified for our steps data frame, and our label will be steps. And here we have it. This is our beautified ADM. And it looks really good, very informative. The last thing I want to show is let's try resampling our data frame so that instead of showing individual minutes, which can be hard to see, we'll instead show hourly sums. Since we worked with aggregating our data frames before using a date time index and resample, this will be quite as easy to do. So let's call steps df 15 for a 15-minute version of our steps data frame. Steps df.resample, and we'll pass in 15t for 15 minutes, and we'll use a sum over those 15 minutes. Then we call ADM beautified, passing in steps df15 and our same steps label. So here's 15 minutes. So we see each one of our little blocks has up to potentially 4 different color blocks in it. And I'll copy and paste this, and let's change this to 60 so we can get hourly, just like Wong had in the original paper. And here is our hourly ADM.